Welcome to Physics with Joe. Today is all about color subtraction, how you add different colored pigments or paints together to produce a variety of other colors. Before we go into color subtraction, I'm going to first review color addition since they're related. And color addition, as a reminder, is how you add colored lights together, which is different than adding colored pigments. So without further ado, let's jump right into it. Let's start with just a quick overview of how vision works. So when light enters our eye, it's focused by the lens onto the back of the eye called the retina. And on our retina, we have different photoreceptors called rods and cones. Rods are sensitive to lightness and darkness, but not color. Cones are how we see color. And we actually have three different kinds of cones, sensitive to low frequencies, red, orange, yellow, mid frequencies, green, and then high frequencies, blue, indigo, and violet. And depending upon how much these different types of cones are stimulated, we see different colors. So let's look at the rules of color addition, which apply when we're adding colored lights together. If you've ever looked at a computer monitor with a really nice magnifying glass, what you'll see is that all the thousands of different colors that a computer monitor can produce are the result of just three different kinds of pixels: red, green, and blue. And any color that we could possibly imagine, any color that you see on your computer screen, is made by adding different amounts of red, green, and blue together. Because of this, red, green, and blue are considered the additive primary colors. So let's look at the rules of color addition. So if I add equal amounts of red and green together, so when our red cones are stimulated just as much as our green cones, we perceive yellow. So our first rule of color addition, red plus green equals yellow. If I have equal amounts of red plus blue, if my red cones are stimulated just as much as my blue cones, then I see magenta. So red plus blue equals magenta. And then finally, if we have equal amounts of green and blue, so if my green cones are stimulated just as much as my blue cones, then I see cyan. So green plus blue equals cyan. And then finally, if all three of our cones are stimulated equally, so I have equal amounts of red plus green plus blue, that's when I perceive white. So the last rule of color addition, red plus green plus blue equals white. And that's equal amounts of red plus green plus blue. Now, if I have different amounts of red, different amounts of green, different amounts of blue, I can produce any other color that you could possibly imagine. Again, that's why RGB, red, green, and blue, are considered the primary additive colors. So in summary, when adding colored lights together, if I have equal amounts of red plus green, that produces yellow. Equal amounts of red plus blue produces magenta. Equal amounts of blue plus green is cyan. And then finally, equal amounts of red plus green plus blue added together equals white. Well, now that we understand the rules for color addition, let's look at them a slightly different way that'll help us in our understanding of color subtraction. Since white is really a combination of red plus green plus blue, if I take white light and I subtract from it the red light, what I'm left with is blue plus green, which equals cyan. So white minus red equals cyan, or another way, cyan is really white light minus the red component. On the other hand, white minus green, what I'm left with is red plus blue. Red plus blue equals magenta. So white minus the green component equals magenta, or magenta equals white minus green. And then last but not least, again, if I take white light, which is red plus green plus blue, and I subtract off all of the blue light, what I'm left with is red plus green, which equals yellow. So white minus blue equals yellow, or yellow equals white minus blue. And we can use these three bottom equations cyan equals white minus red, magenta equals white minus green, and yellow equals white minus blue to start understanding the rules of color subtraction. So let's look at color subtraction now. If you've ever bought ink for your printer before, you know that the colors of ink you buy are not red and green and blue, the additive primary colors. And the reason is because pigments in ink and dyes and paints act differently than light. A pigment cannot emit its own light. All it can do is take white light from a source such as a light bulb and absorb specific frequencies of that light, reflect the rest. So for example, yellow paint appears yellow because it is absorbing blue light and then reflecting red and green together. Red plus green equals yellow. That's why we say yellow equals white minus blue. So a yellow dye is taking white light from a light bulb, it's absorbing the blue component, it's reflecting the red and green. Red and green together is yellow, which is why we see yellow. So something to keep in mind is the color of a pigment, which is just tiny particles that absorb specific colors, is the same as the color of light that it reflects. So a magenta pigment is magenta because it's reflecting red plus blue and it's absorbing green light. So magenta equals white light minus green light. So magenta dye takes white light from the light bulb, absorbs the green, and then reflects back red and blue. Red plus blue is magenta. So keeping that in mind, let's take a look at the rules of color subtraction and how they come about. The subtractive primary colors are cyan, magenta, and yellow. And these are the different colors of ink you'll buy if you have a color printer for your computer. Now, you will usually also buy black, but you really do not need black. You can produce black by combining cyan, magenta, and yellow. So let's look at the rules of color subtraction that apply when we're mixing colored dyes, inks, or paints. First rule, cyan plus magenta equals blue. So equal amounts of cyan and magenta added together produce blue. Cyan plus yellow. Equal amounts of cyan plus yellow produce green. So cyan plus yellow equals green. And then finally, magenta plus yellow equals red. And then if I have all three together, cyan plus magenta plus yellow, I get black. So one more time in summary, I have cyan plus magenta equals blue, cyan plus yellow equals green, magenta plus yellow equals red, and then cyan plus magenta plus yellow equals black. Now let's take a look at where these rules for color subtraction come from. So again, color subtraction is different than color addition when we're adding colored lights because pigments do not emit their own light. All pigments do is absorb specific frequencies of light. Remember, cyan pigments absorb red light, magenta pigments absorb green light, and then yellow pigments absorb blue light. And we're going to assume that we have white light shining down. And remember, white light consists of red plus green plus blue together. So cyan plus magenta. Cyan is absorbing the red component of white light. Magenta is absorbing the green component of white light. So when I take white light and I subtract red and green from it, what I'm left with is blue. So cyan plus magenta equals blue. Cyan plus yellow. Again, cyan is absorbing the red component of white light. Yellow is absorbing the blue component of white light. And when I take white light and I subtract off red and blue, what I'm left with is green. So cyan plus yellow equals green. And then magenta plus yellow. Magenta is absorbing the green component of white light. Yellow is absorbing the blue component of white light. And when I take white and subtract green and blue from it, what I'm left with is red light. So magenta plus yellow is red. And then finally, cyan plus yellow plus magenta. Cyan is absorbing all the red light from white. Yellow is absorbing the blue light. And then magenta is absorbing the green light. So when I take white light and I subtract off the red, the blue, and the green components, I'm left with no light, and whenever I don't have light coming from a specific spot is when we see black. So cyan plus yellow plus magenta equals black. Well, that is the rules for color subtraction. Thank you so much for joining me for this episode of Physics with Joe, and I can't wait to see you next time. So until then, happy physicking. Happy physicking. Happy physicking. I'll see you next time.